The question we are solving now belongs to test series 6. It is of control system subject. In specific, it belongs to frequency response analysis of control systems. The question is numbered 33. As per the question, the open loop transfer function of a control system is given as g of s into h of s is equal to k by 1 plus st1 multiplied by 1 plus st2. It is of unity negative feedback. We need to find the Nyquist plot of the control system. Put s is equal to j omega in the given g of s multiplied by h of s. We get g of j omega multiplied by h of j omega is equal to k by 1 plus j omega t1 multiplied by 1 plus j omega t2. Put omega equal to 0 plus. From this, we get that g of j omega multiplied by h of j omega is equal to k, and substitute omega equal to infinity plus. From this, we get g of j omega multiplied by h of j omega is equal to 0 phase minus 5. Also, by splitting the given g of j omega, h of j omega into real and imaginary parts by rationalizing, we get g of j omega, h of j omega as shown, which is k into 1 minus j omega t1 multiplied by 1 minus j omega t2 divided by 1 plus omega square t1 square multiplied by 1 plus omega square t2 square. From this, the real of g of j omega h of j omega is k into 1 minus omega square t1 t2 divided by 1 plus omega square t1 square multiplied by 1 plus omega square t2 square. Also, the real part is 0 for omega is equal to 1 by root t1 t2. So, Nyquist plot intersects with imaginary axis. Also, the system is type 0 system. That implies there will be 0 encirclements as omega varies from 0 minus to 0 plus. From this, the Nyquist plot of a control system can be drawn as below. At omega equal to 0 plus, g of j omega h of j omega is k, and as omega tends to infinity, g of j omega h of j omega is 0 minus 5. So it approaches origin, but the condition is that the Nyquist plot intersects with the imaginary axis. So the Nyquist plot can be redrawn as shown. Similarly, the this is the Nyquist plot for omega equal to 0 plus to infinity plus, and we know that the Nyquist plot for omega equal to infinity minus to 0 minus is symmetric, which will be as shown. As the system is type 0, there will be 0 sorry there will be 0 encirclements about origin. So the Nyquist plot of the control system is as shown. From this, the correct option is B. So the Nyquist plot obtained matches with the Nyquist plot in the option B.